Hi, I'm Shane Franklin from the University of Delaware, and today I would like to give you a short presentation about my paper, More Than Meets the Die, Evaluating Preferential Flow Paths as Microbial Hotspots. Preferential flow has been studied for decades as they play a key role in contaminant transport, but most of this research has focused on the physical properties of the flow paths, resulting in very little information on the processes that are actually taking place within the flow paths. Oftentimes, these flow paths will be dyed with blue food coloring to expose their locations, but further examination is rarely done. So in this work, we take a peek inside preferential flow paths, and our results suggest that there may be more to these pathways than we previously thought. So with that in mind, let's get started. Our motivation for this work comes from Bunt et al. 2001, where they showed that preferential flow paths contained higher contents of carbon, nitrogen, and microbial biomass. However, high biomass does not necessarily equate to high activity. So in order to investigate this further, we monitored oxygen saturation along artificially created preferential flow pathways. Our objectives were to determine if flow paths could function as microbial hotspots and to determine hydrology's role in the development of these, and also to demonstrate the feasibility of using oxygen-sensitive optodes to monitor oxygen depletion by microbes along these flow paths. To create preferential flow scenarios, contrasting fine and coarse sand textures were packed into three unique configurations. A soil slurry containing the native microbial community and a glucose addition was flowed through the sand. You can see here accumulation along the interfaces of the sand. Oxygen saturation was monitored using the VisiSens camera from Presens. Oxygen depletion served as a proxy for both the intensity and location of microbial activity. So what do we find? The images you see here are from three separate treatments at independent time points. The darker the color shown, the more oxygen depleted the area is. For each of these three scenarios, we've taken images at 15-minute intervals and composed them into time-lapse videos, but unfortunately for this presentation, I could not get them to cooperate with me. So if you'd like to watch them, please see the supplementary info for the paper. Nonetheless, these images clearly show that flow regime played a key role in the distribution of oxygen depletion. Here, the top row of images shows the average of all the images we took at 15-minute intervals. The bottom shows the positioning of oxygen depletion within the textural makeup of the chambers that we've packed with these sands. And this comes from this black rectangle this oxygen pattern does. And so what we find is that oxygen consumption is occurring in localized, distinct regions for A and C. And for B, we have found that this oxygen depletion pattern is very similar to that of aggregates, in which case oxygen consumption is outpacing oxygen diffusion. And you can see Sexton 1985 for a comparison on that. So in conclusion, our results suggest that microbial hotspots are localized along and adjacent to preferential flow pathways. Hydrology played a significant role in the spatial distribution of oxygen along the pathways. The oxygen-sensitive camera allowed a glimpse inside these flow pathways. And finally, the biophysical properties of preferential flow paths remain largely unknown, although we are excited to continue researching this topic and eager to see what we will find. Thanks to Dr. Xianjin and Dr. Bruce Vasilis for their help on this work. And I thank you for listening, and I hope you enjoy our paper.